I tried to contact her this morning, but it's not going through. It was not going through.
Because she's missing my classes. So what time do you guys close for the day? What time is your last class for today?
At
Uh,
5.
our last class will be 5:15.
Oh, okay. That's almost 6 a.m. All right. Let's start and see. Actually, I have not been around, so and I was a bit tight during the week. I couldn't get things well structured. But let's start. Yes, motion in one dimension. Can you hear my voice?
We
Yes,
can
sir.
hear you.
Yes, so today's lesson is motion in one dimensions. Anybody try reading something on that? Somebody try reading something on that. Somebody try looking at it, what exactly it is you want to talk about. Somebody, you are all busy chasing money. Philip,
Yes, somebody.
who is that somebody?
Yes, sir.
Philip, we are all just chasing money, eh?
Yes, I tried looking on, and I tried looking at it a bit.
It doesn't make sense.
Uh, it makes sense.
You try looking at it, doesn't make sense, eh?
It makes sense. It makes sense.
Eh,
Yeah, so I look at when we talk about the one dimension. So I thought I look at the first we have position and then distance, then we get the displacement, where the location of an object to
oh, you have done well. Let's clap for him. You have done so well. I think you have an idea about what we are coming to talk about. That is true. At least it's a common knowledge that we all know the position, the velocity, the speed, acceleration. Those are the basic things that we are to talk about. So if you're able to take, yes, if you're able to open it, you get to understand all this. You don't need anybody to help you to do this. It's something that you have done over and over again. Yes, SHS, whether you were a student or not, you do it. So, motion in one dimension. So that is what we are to talk about today. And what I always expect is that sometimes when you make time and glance through, no, internet is closer to us. Just drop it in. It will give you a lot of information. So when you come to class, we're shaping it up. Maybe sometime maybe I may not consider certain things, but you are the one coming to teach the class. Yes, university level, you are the one leading the class. I'm just facilitating. So you enjoy the class when you participate in the class. So I encourage you to make time out of your busy schedules and read something. Yes, and read something that will help you. You learn for life, not just for exam. No, don't learn just for exam. If you learn for just for exam, if you need exam, then everything is gone. But learn for life. You enjoy it. Just learn for life. We are all chasing the money, but let's make time to add some value to ourselves. So today, what will be the objectives? So at the end of the session, we are able to describe the position, velocity, speed. So these are the basic things that you are expected to be able to do after the end of this. Discuss the instantaneous velocity and speed. So we describe particle under constant acceleration. So we should be able to do that. We should be able to do that at the end of the lesson. We should be able to do that. Yes, we should be able to do that. Actually, I try, but as I said that this particular week I was away, so I couldn't get the slide sets, especially giving you examples to solve plenty. I couldn't do those ones. So what's going to happen is that after the class, I'll get some examples for you to try your hand on and send the note to you, because mostly my notes are self-explanatory. So when you take it, you should be able to understand my slides. So what do you understand? And able to do it yourself. You don't even need me to learn. So that's what is going to happen for today, my today's class. So motion in one dimension. As a first step in studying classical mechanics, we describe the motion of an object. So we should be able to describe the motion of an object. And kinematics as part of the mechanics that describe motion without considering the force that causes it. The how. You are describing a motion without considering the forces that cause it. That's what we call the kinematics in mechanics. So we are going to look at it and see. So the word mathematics has the same root as cinema. Hey, your time, have you been to any cinema before? Who have been to cinema before? Philip, you don't like movies?
So we, so me, I grew up in a village, so that thing I've never seen it physically before.
Oh, really?
Yes, sir.
Who have been to cinema before? Who is here? What did they do at the cinema? Alpha. Yes, I know you know, but tell me.
So it's a place where movies are shown.
So have you been there before?
No,
Oh, why?
I watch the movies in the house.
Oh, that's so.
Yeah.
Oh, you don't like the fun, eh?
Yeah, and the time and all that.
The football too, you watch it in the house, eh?
Yes, sir. Never been to the stadium.
Eish, this guy, you don't know the fun. All right, so basically, if you have watched movie before, you understand what we want to talk about. Just as a movie in a sequence of images showing the changing position of the actors and the objects. So when you're talking about kinematics, we're just trying to look at something in this nature. So you are just trying to look at the images showing the changes position. You want to see the position change. They're moving from one place to another. So the position of the actor and the object. So that's why the kinematics and the cinema, they have the same roots of generation. So basically what we are trying to link the kinematics to cinema is that the sequence of the images in cinemas showing the changing position of the actors and the objects. So kinematics is the mathematical description of the object changing position over time. So when the object is changing position over time, that's what we are describing as the kinematics in mechanics. So if you are going to study a topic called kinematics, that means you are going to describe an object's changing position over time. So basically that's what we're in the process of talking about. So if you want to talk about one-dimensional motion, what exactly that we want to talk about? One-dimensional motion. What exactly that we want to talk about? By starting with motion along a straight line, we dramatically amplify the mass. We only need to worry about one coordinate. So if you're talking about one dimension, then we have to do with only one coordinates. We have the x and y coordinates. By here, we are dealing with the x coordinate. That means you are moving horizontal movements, not vertical movement, horizontal movements. So we are only need to worry about the coordinates and its direction. So you are moving, and what direction are you moving to? Is it a vector quantity or is it a scalar quantity? When you say something it's a vector quantity, what does it mean?
Because they have magnitude and direction.
That's magnitude and direction. That's true. All right. So now what you have to look at is you want to model the particle. So this arguably the most important amplification in physics. We treat an object as a particle. So every object that we are dealing with, we treat it as a particle. That's how we are going to look at it. A point with mass, but no size. So a particle is having mass, but sometimes you may not even see the size of it. We do this when the object's size and shape are not relevant to the motion we are describing. So the shape and the size of the objects are not relevant to the motion we are describing. The car is moving. We are not interested in how big is the car. We are not interested in how many passengers I can carry. But what we're interested in is the motion. So those things doesn't really, we don't need it. So that's what we want to look at. So let's look at example, the Earth. You know the diameter of the Earth? You know, it's tiny compared to its orbital radius. For calculating its orbit, treating it as a particle is perfectly fine. So if you want to calculate it, we treat it as a particle. You don't look at it as a big object. No, treat it as a particle. So that's how we're able to get in physics. That's how we look at it. So when calculating pressure, we only care about the mass and velocity of the molecule as they collide with the container walls, not their internal structure. So what you're trying to look at is the mass and the velocity. That's what you're interested in. How do those mass and velocity, how does it affect their movement? That's what interests. But whatever that is happening within the container, you care less. So that is kinematics. So we have some types of motion. So when somebody talk about translational motion, what is it talking about? So we are trying to look at movement from one point to another. This is what we'll be working on throughout. This is where we are going to focus on, like a car driving. So that is translational motion, movement from one point to another. Translational motion. But we have rotational motion too. That's spinning around an axis. So, the earth spins, so it's into rotational motion. Vibrational motion, back and forth movement around a central point. As you know, pendulum or the guitar strings that you are trying to play. So these are the type of motion that we have to deal with. These are the type of motion that we have that we are going to deal with. So now what we want to focus on is we'll deal with only the translational motion. That's what we are going to deal with. So for it to continue, our first objective is to describe position, velocity, and speed. Are you there?
Yes, sir.
All right.
Yes, sir. Yes, sir.
I just want to be sure that I'm not off. So this is the first step in our kinematics analysis. Once we have simplified our object to a particle moving in one dimension, we need a language to describe where it is, that is the position, and how fast, in what direction it is moving. The fast and direction, velocity and speed. So as we're able to describe, as we're able to simplify our objects to a particle moving in one dimension, now we can describe where it is. That is what we are talking about, position. How fast, in what direction it is moving. That's velocity and speed. So the second objective, this is the refinement of the objective one. So that's the average velocity. Often we need to know this velocity at a specific instant. This is where calculus comes in, allowing us to move from one average over a time interval to the exact value at a single moment. Yes, so calculus. Any of you here who have not done integration differentiation? Is there somebody here? Is somebody who have not done elective maths?
Yes, sir.
You haven't done elective maths?
Yes, sir.
And who else? Who else have not done elective maths?
Tell me too.
You too.
Yes, sir.
You have not done elective maths. So who else? Me three. Who is the me three?
Is that me?
Oh, Asar is the me three. And then who's the me four? Oh. So about 3 people have not done elective maths. Okay. We'll look at it and see. It's a simple procedure that you need to apply in this instance. So the third objective, describe the particle under constant acceleration. This is a specific, very common, and mathematically solvable scenario Once we can describe velocity, the next logical question is, how does that velocity change? The change is acceleration. The case of constant acceleration is the foundation for solving many real-world problems, like car accelerating or a ball falling under gravity. So these three objectives should be able to get closer to achieving our goal. So we are looking at the moving objects, which could be a car, a ball, or a person, as a particle. So we are trying to model these things as a particles. So the first thing, define its motion along a straight axis. So the straight axis, that's what we are talking about, one dimension. Straight, single axis. So if it is one single axis, we are talking about one dimension. So use the position, velocity, and speed to describe its motion. Then we can use the instantaneous velocity for more precise description. Analyze how its velocity changes using the concept of acceleration, focusing on the powerful case of constant acceleration. So now, defining the terms one by one. Position. Position basically means the location of the particle relative to the chosen origin. So your position, where are you? What is your position now? And basically the position may have magnitude and direction. So it's a vector. So the position is a vector. Are you sitting at the northeast? Are you at the south? What is the distance? So measure directly from the reference point. So the reference point that you are measuring from, so where? Is it from the northeast? Where are you located exactly? You can describe that place for me to come there. So it can be positive or negative. It can be positive or negative. It can be positive or negative. So now, displacement. Change in position of a particle. Vector. It's a vector quantity. So you're moving from the initial to the final. So that is displacement. Can be positive, negative, or zero. It only depends on the start and the end points. So if I may ask, what is the difference between displacement uh, all right, so distance. The distance is the total length of the path taken by the particle, and it's a scalar. The sum of absolute values of all individual displacements is always positive number. It depends on the entire path. So the question that I was about asking, what the difference between displacement and distance? How do you understand those two words? Displacement and distance. What can you say about them? Yes, who is talking?
So, hello, sir. For the displacement, it's a vector quantity, and the distance is a scalar quantity.
Okay. Ernest. All right.
Yes, yes, sir.
Who else? Displacement and distance. What do you know about them? What's the difference you think? Displacement and distance.
Okay.
Yes.
Yes. So the the distance is the the distance is the total length travel, which is a scalar quantity like what my brother said. And then the displacement is defined is the change in uh the change in the position. So like the difference the difference in the between the final location and the initial location. That's the displacement.
All right. Good attempt. Good, good. That's fine. Let me use a basketball player to illustrate the difference. So a basketball player runs from one basket to the other and back. So now let's look at the displacement. Their displacement is 0 because they ended up where they started. So displacement is 0. What about the distance? The distance travel is twice the length of the course. So the distance that you travel from one end and back. So it's twice the distance that you travel. But the displacement is 0. Does it make sense to you? Ernest?
Yes,
Because
sir.
he make a move from initial
Yeah,
origin. And
yeah.
so let's say the initial origin is point A and he travel to another pole. That is point B.
Okay.
Uh,
Then he came back to A.
okay.
Yes, displacement and distance.
Eh,
Don't forget, displacement is the final position minus the initial position. So you have started from a point and you came back to the same point. Displacement is 0. Does it make sense to you?
Yes, sir.
No, you can use mathematical way to solve it. The change in x, that's the displacement. So the initial minus the final. So if the final is equal to the initial is 0. So you're telling me that this was equal to this. So the displacement is 0. That's what it
yes, sir,
means.
is zero. Is zero.
Do you agree?
Yeah, is zero.
Yes, that should be 0. So this is a clear distinction between displacement and distance. Sometimes we try to use them interchangeably, but they are not. Displacement and distance. So the displacement is the final position minus the initial position. But when you talk about the distance, you are summing the absolute value for all the displacements. So the first displacement to the basket and back. So you're taking 2 of that displacement. So it gives you twice. That's what it means. So the rate of motion, velocity, and speed. These are another 2 words, velocity and speed. What's the difference between them? What's the difference between velocity and speed?
So with velocity and speed, velocity is a vector quantity and speed is a scalar quantity.
Okay. I want the mathematics. Velocity and speed. So what's the formula for velocity? Yeah.
Displacement per time, rate of change.
All right.
Hello, sir.
Yes.
Right. I was saying the rate of change of displacement per time.
All right. That's what about velocity? The speed.
And the speed too is going to be rate of change of distance per time.
That would be the velocity. That would be the velocity.
Okay.
So in calculus,
Sir,
yes.
please, do you have a average velocity before we have velocity itself?
Yes, we can talk about average velocity.
Okay.
So what is that? What is average velocity?
So please,
What is average velocity?
so that one is the ratio between the displacement and time interval.
No, that cannot be.
So is the displacement divided by the time interval. That's the average velocity.
Average velocity. Okay. It's the total displacement over the total time taken for that displacement to occur. That will be the average. It's just like when you are drawing the velocity time graph. I think have you drawn that before? Have you done that before? Velocity time graph. And then the area under the area under the shape. It will give you what? The total distance travel. The velocity over the total distance travel will give you what? So basically, we are just looking at the distance over time. So you're able to get either your acceleration or your speed. acceleration or speed, what we are talking about. So average velocity is the displacement per unit time. So it's the distance over time. That's average velocity.
But
But
sir, then
basically,
it's the same as the velocity.
yes, that's what I was trying to tell you, that if you're talking about average velocity, you are talking about the total distance over
Yes.
the
Okay.
total time taken.
Mhm.
You get it? So that's what talking about. But they are all the same thing, but depend on at what point are you finding it.
Okay.
The
Okay.
distance is, yes, depend on where you are finding it. But they all use the same formula. But the
Okay.
value put there will differ from which one are you finding. Velocity for the whole journey, or for the first journey to this, the second to this. And you add them up, you divide by the total, and you get the average. So that's what it means. So now, when we talk about the average speed, total distance over time. So average speed. So it's just like a acceleration. What do you call it? The speed, the total distance that you covered. Within what time have you covered that? So average speed, average velocity, average speed, and average velocity. So now let's try and get some difference between this. We use the average attached to them because that one gives you a more precise values than just the velocity or the speed. So let's look at this scenario. The airport traveler. So the first motion, travel 100 meters down a hallway in 45 seconds. The second motion, travel 25 meters back in 10 seconds. What's the total time used? That will be 55 because you are adding the 45 to the 10. So what's the final position? You subtract the 25 from the 100, so you have got to 75. So what will be the displacement? The displacement is the initial from the final. So our final is 75, so the initial is 0. So you are going to have a positive direction of 75 meters. So the average velocity, we had the displacement over the total time taken. So you know that the movement were 2, so we must be able to add them all together to be able to know exactly the average velocity. It's difficult to find it for 111, but this one you put them together. So you realize that everything that were involved is what we are using to be able to calculate that. So when you divide it, you have 1.36. That's positive sign indicate the net motion is to the right. So the total distance travel, will be the first 100 plus the second 25. That will give you 125 meters. So your average speed, the average speed will be equal to the total distance over the total time taken. So this one will give you 2.26. So what the difference? What can you observe from here? Average velocity and average speed. What can you observe from here? Average velocity and average speed. What are your observations from the calculation? What are your observations from the calculation? Oh. No, average velocity and average speed. But could you observe that the average speed is greater than the average velocity? Why?
So
Yes.
I understand the average speed in the sense where the distances, but with the velocity, velocity is really somewhere. But the differences are in the distance and the displacement. That's the difference.
The distance and the displacements. Yes. Any other observation? Any other observation? So we are talking about displacement and distance. So when the motion go and come back to the same position, the displacement will be zero. So that's the difference that you could observe. So it should always be, but when there's a return, when it's a continuum that is has not return, you may not see it like this. Are you following?
Yes, sir.
So the average speed is greater than the average velocity.
Yes, sir.
Yes, so that's how it's supposed to be. But when you reverse, it will not be so. So you take note of that because of how you define displacement and distance. So these are very crucial that you must take note of. The difference between displacements and distance. That's what will be affecting these values. So if you say displacement, you go and come back to the same point. The initial minus the final will give you 0. But the distance will be twice the distance travel. Twice the displacement. So I'll give you the distance. So we'll be able to get this clear. The rest will fall in place. This is a key thing that I want you to take note of. It will be so much interest. Yes, we call something instantaneous velocity. We have velocity, but we have the instants, what you can observe instantly when you are driving. Instants. Average velocity is useful, but it is a summary of the motion over time interval. So the motion over time interval. It doesn't tell you what happened at any specific moment within that interval. For example, your average speed on a road trip might be 60 meters per hour, but you certainly were not going 60 meters per hour when you were stopped at a red light. So you are driving at that speed, but along the way, it may reduce. Some obstacle may cross, must reduce. There's some ramps you have to reduce, but you are assuming that you are going 60 meters per hour. But that is the average velocity. So all those things will take everything together and divide it. But we want to go into details. Instantaneous velocity answer the question, what is my speedometer reading at these very seconds? It describes the motion at a single point in time, not over a duration. Have you gotten the explanation? Does it make sense to you?
Yes.
Instantaneous velocity and a velocity. So the instantaneous velocity is when you're using your speedometer, you are in your car. So when the car is moving, you could see and you have come back. So at what point? The motion at a single point in time, by the average velocity, take it over a duration from here to Akosombo. So you have taken all over the same stretch. But the instantaneous from here to boom, what was the speed? So each of them will be taken care of at that instance. So looking at this graph, which I need to do more if I've made time to prepare my notes. A bit different, but that is what I will send to you. I will get a better note and send to you for you to read because it will be more explanatory. Average velocity is the slope of the line. Average velocity. So a straight line connecting two distinct points A and B. This is the position time graph. A and B, A and B, the point connecting A and B. So that is the average velocity. That's the average velocity. That's the slope. You are taking the slope of your line. You were to calculate the slope, or what we normally call the gradient of the line. So if you find that gradient of the line, so now instantaneous velocity is the slope of the tangent line. The tangent. The slope of the tangent line that just touch the curve at a single point. So this one, look at the the graph on your left at that green point. So that's the instantaneous velocity. Is the slope of the tangent line that just touches the curve at a single point. But when you're talking about the average velocity, that is the slope. That is the slope between the A and the B. But instantaneous velocity slope. So let's get this. So instantaneous velocity equal to the limiting value of the ratio. So now for the calculation, change in the distance over time, and at the time the t is approaching 0. That's the limiting. So this is the equation we use to calculate the instantaneous velocity. So at which point in time? So have I slowed down? Yes, this time, the time is this. So you put into the equation, you're able to get your instantaneous value at that time, at that point. So each of them, so they will vary, depend on what is happening at what time. But not to take the whole durations and divide it, no. But this one, you are trying to look at it within what time, what is happening. So that's the instantaneous velocity. In calculus, what we normally call the differentiation. The limit is called the derivative of the s with respect to t, which is written as. So we have to do this derivative. Know how to use the derivative. It will make our calculation very simple and things will move very faster. When you are calculating the instantaneous, the question will come, you will do the ds over dt so that you can get your speed. Because the velocity, when you differentiate the velocity, you get a speed or acceleration. You differentiate it, you're able to get that. So that is what is going to happen. You differentiate the distance or the displacement, you get the velocity. Differentiate the velocity, you get the acceleration. So that's how calculus will show you how to go about it. I hope everybody knows that when you differentiate velocity, you get acceleration. Unless the 3 people who have never done calculus or who have never been elective math students. It doesn't make sense to them. But what we mean is that when you differentiate with respect to that value, you multiply top and you subtract 1 from it. So what is holding? That's the differentiation. Differentiate of this. So the s over the t. So you're able to have that tan. But when we get, we'll try to get it done more. Oh. All right, so instantaneous velocity. So as we are trying to explain further, that the slope can be positive. That is moving in the plus x direction. Can be negative, moving in minus x direction. Or 0, momentarily at rest. So this is a scalar quantity. It is simplified. It is simply the magnitude. So if you are talking about that, the magnitude, absolute value of the instantaneous velocity. So instantaneous velocity, we normally write it in this form, and the magnitude of the v. So if you want to find the magnitude of the velocity, then you are able to get the square of those values. So this is what we are to look out and understand how we apply them. So these are the basic explanation to what we are going to do. And then we take each examples to solve, which I am going to do for you. Any questions so far? Anyone with a question? Do we have Ernest?
Sir.
Are you there?
Sir, please, can you please go over the equation again for me?
What
The,
equation?
the calculus.
The calculus.
Yeah.
The calculus,
The,
it
the
will be
use
best.
the use of the limit and the change, the derivative.
I could have put some into writing for you to see. Calculus, what we normally do is that, let's see, let me show you something. That's what I mean. I mean that my usual notes, this is not complete, so I wish I will do it when I'm sending you this one. I will explain it. You see, with this ds over dt, what we normally do is that the x here is assumed that the power is 1. So if the power is 1, you use the power to multiply. If it is 1, you subtract 1 from the 1, it gives you 0. So the whole of this 1 will go. And you multiply with the value. So when you are differentiating a number, let's say just only t, it will give you 1. But let's say you are differentiating t raised to the power 2. T raised to the power 2. You use the 2 to multiply. You subtract 1 from that, so it give you 2t. 2t means 2t raised to the power 1. You subtract 1 from the 2, so it give you 1. But the 2 will multiply at the back here. That is the rule that we use. But I will try and get it in a simplified form so that you can follow through. That's how we do the differentiation. But in this case, when the t is approaching 0, so when they give you the instant that the time is 5, so you put 5. The distance is the change in the distance is from 5 to 10. That's the change in the distance. So you take the difference of those two, will give you the change in x here at the time t 5. So if that's at the time 5, and then you put t as 5, and then how do you get it? So the t as 5, so you're able to get the value at that instant. So this one is just a matter of knowing at what time, at what distance, and what's the time that I'm using. Your speedometer, what's this reading? It's reading 5. It's reading 50. So you put in the 50 here to be able to calculate the average speed at that time, then all the instantaneous speed at that time. As for this one, is a bit difficult to explain online, but maybe when I put the calculations together, you should be able to follow through But because I have not done it, I don't know how you understand it as I'm explaining. But calculus is a basic rules they have to follow. Those people who have done it, I'm not sure they have a problem with it. So we'll get examples and solve on this instance to be able to get this one sorted. So I will take care of that for you. Any other question? Any other concern that we need to look at that you are not getting?
So it says, please, is this a final standard formula or is just approving, like proving the formula?
Yeah, you see, sometimes they may give you an equation. Let's say you have been given, you have v plus 2t squared. 2t squared. So what you are going to do is that you differentiate the t's. Constant, when you differentiate constant, you get 0. But you differentiate the t's, so you get 1. So when you are differentiating the value, depending on what is given to you, and then you're able to apply that rule. This is the formula. That is the final formula. But how to apply it is what I will give you example to apply. And I have to write example for you to look at. But here, I don't know how I will do it, but I will add it to your notes so that you solve more example to be able to get it. So if I send it, when you go through our next meeting, you should be able to, if you're not able to get it, and let's talk about it. Let's talk about it. But in addition to, I wish that later, if you can find one day for me, I'll be grateful to get this example solved. Apart from our normal meeting days, because I'll get the notes ready for you today so that we can go through. So what will happen is that when I give you the notes, maybe if you don't really get it, you guys can make some time for me to finish up this. Because I wasn't home, that was why I couldn't get this thing sorted. I could have given you all the details about it, but I have been out for the whole week. Yeah, I've been away for the whole week, so I couldn't sit down to look at these things. So I'll get it sorted today. Not for today. I'm going to get the whole topic straight to explain, get you some pictures that will depict what is happening so that you can appreciate the exact thing we are talking about. But basically, this topic is about velocity, like we talk about distance, velocity, acceleration, or speed. That's all it's about. But how you're able to put these things together, that is what we need to understand. But for what it is, we all know. We all have heard it before. But I want you to be able to differentiate the two when you see them, not as general as the way everybody talks. No, I just want you to understand it. What the difference between displacements and distance. You should be able to get it clear. Never get confused about the two. What the difference between displacements and the time. So that's what I was trying to take my time to be able to illustrate and get you some pictures that you can easily be able to assimilate quickly enough. Yeah, that's how I always want my notes to be, so that you easily understand it. But for this week is exception because I was not available. But I promise to send it back. I'll send it to you today. I will send it to you today to look at it. If there is a need, talk to yourself and let's see. We can find some day within the week, as you are within the week in the evening. We can do something in the evening. This one we have to solve some few examples for everybody's understanding. So the class can arrange one class in the evening that we can use to do that. Is that possible?
Yes, sir. We'll organize. Then we'll let you know.
Yeah, that will be fine for me. I will always want you to get not the normal thing that we do, but I just want you to get it. But the basic principles are the thing that I've just talked about how to give you the details examples. That's what I want us to do together. Yeah, I want us to do together. Get you some instances, how you can differentiate between them. The average velocity and average speed, how you can differentiate between distance and displacement. So things like that sorts are things that I would love you to look at. I am not necessarily about exam questions. As I always tell my students, don't learn for exam, but learn for life. So I want you to understand the concepts, how you're able to apply the concepts, and how you can design your equipment to use the concepts. Physics is all about concepts. Yes, how you can design your equipment to be able to use the concepts. That's the most important. When you understand the concepts, you can turn it anyhow. That will give you a result. And see, that is what exactly that you want. That's what we want to do. That's what we want to achieve. Exactly. When you differentiate velocity, you get acceleration. When you differentiate a distance or displacement, you get a velocity. So you just move in that dimension. If you want to come back, you integrate from acceleration to velocity, you integrate. From velocity to distance, you integrate. But when you're going forward, you differentiate the two values. That is mathematics. But it's a concept that is applied in physics. So if you were to have that basic knowledge, and it's something that you use in your electrical program, so it's a matter of getting the concept. If you get a concept, the rest will fall in place. Any other concern? Any other question? Jehoshaphat. Jehoshaphat, can you hear my voice? Hello? Raymond. Raymond, don't come. Are they the only people who are not hearing my voice? Or
Hello,
Yeah,
sir.
we are
I
hearing
can
you.
hear your voice.
Jehoshaphat, you can hear my voice.
Yes, please, I can hear you.
But I was calling you. I have not hearing the response from you.
Yeah, sorry, my internet got cut for a couple of minutes. I just rejoined and then I heard you mention my name.
Have you gotten the difference between the displacement and distance?
Yes, please.
Oh, okay. Raymond. Raymond, don't call. Raymond, don't come. But your colleagues,
Ceremony is a
Raymond is there. Yes, so for now, I think Alex, no, as I said, when you join the class, yeah, when you join the class, write your full name because I take attendance. Those people who don't, because as I know, you have not gotten the full house yet. At every point in time, some people have not joined. So you should be able to differentiate between the people who come to class and people who don't come to class. You should be able to differentiate them. We can't differentiate it from the results because some people can learn and get the answer correct, but it's different from coming to class. So when you join, make sure that you give me your full details for me to take a screenshot of for my record. For my record, I can keep that set. So for today, if you don't have any question, I want to say that we'll relook at this again before the next class. As our outlines are clear, try and look at the whole things, what we are going to do the next week. You should know it ahead before we meet. So, Philip,
yes, sir.
yes, so for today, I am done.
Okay, sir. Okay, sir.
I have taken my attendance too, so if there's any other thing, let me know within the week, okay? But today, I promise to send the slide, okay? I'll finish it right now and forward it. Enjoy the rest of the time.
Okay,
Bye-bye.
sir. Thank you.
Bye.
Bye, sir.